Good morning, folks. This is week 11, the first lecture, and we're going to start the subject of parameterizing a solid part, which I actually initiated it on Friday's lab and do several problems. Okay. Later on, not today though, we're going to be doing a parameterization of an assembly. Okay, several parts, but for now, it's a single part. So on the agenda, this is what you've got. And one of the things that we have to do is to make sure that you all know how to display the parameters in the tree. I already alluded to that. So you've got to go to Tools, Options, Infrastructure, Part Infrastructure, Display tab. And when this thing opens up, you really need just parameters and relations, but I suggest you do constraints too, but it will not affect what we have in mind today. All right, so let me make sure that I have them here. Here is my CATIA, Tools, Options. Any settings can be done from this window. And notice that there's the infrastructure, and there's the part infrastructure, and here's the display tab, and these things are checked. Okay, so I don't have the problem. Now, let's go here and see what is it that we have to do. So I'm going to create 5 parameters, and these 5 parameters refer to the height of the path, the big radius, the radius of the holes, and the radius of the circle along which the center of these holes are located. Also, n is the number of holes that you will have in this complete crown. Not cloud, crown, complete crown. Okay, so let's go ahead here and create we can do that right now. We can go and create our parameters, or you can do it after you actually create the model. That is entirely nominal model. That's entirely up to you. Let me do that now. So you go to f of x, find the f of x icon here, right there. And notice that down here, you have the different parameters and different types that you can create. First, let me do everything that's length, and then I will do n that has no dimensions associated with it. The 6 holes, the 6 has no dimensions. 7 ice creams, the 7 has no dimensions, okay? So first let's do the ones that do have dimensions. So these are length, all length type length, and you say new parameter, and I'm going to call this thing h, and I'll give it some nominal value, 1 for example. And I tell you why, because if you let h be equal to 0, there is no issue with it. It's just the padded height will be 0. And then when you might get a warning message or error message, etc. Just give it some meaningful nominal values, okay? Another one, R big, right? R big. So what was R big? R big was the radius of this big circle. So let me make it, for example, 5 inches. Apply. New parameter. Let me see now. What's the next one? R hole. So here R, big R, hole. That's the radius of the hole. So let me for now make it 0.2. Okay. Another one. What's the other one? R mid, I think. R mid, yep. R mid. That's the radius of the circle, or the center of these little tiny holes are located at. So obviously that should be less than R big. So why don't I make it, I don't know, maybe 4, okay, 4 inches. Now the last thing that I need to do is the number of holes. So the type does not have any dimension associated with it. Like CATIA, those things that don't have any dimension associated with them is called real. Click on real, so type real, new parameter, and call this thing n. Okay, apply, Okay, now, if you go to the tree, these are created. Oh, I didn't want it to be 0, by the way. So let me make it, I don't know, maybe 6 for now. Okay, you can change these things from here. Obviously, I don't have a part. If you double click, left click twice on it, you can go and change these things. But now we're going to leave it the way it is. Okay, so on a convenient plane, on that horizontal plane, I will sketch a circle. And because later on I'm going to say this radius is equal to r big, I better dimension it. Otherwise, I can't say this radius. Okay, so right now, all right, let's do another one, which is here. Okay, and well, actually, you know what? Let's get rid of this for a second because I want to show you a different way of doing it. Exit, pad it, okay, and then say okay. On that face, I will sketch a circle right there, but this is going to be a construction circle because all I do is to place the center on it. For example, I mean that's obviously there are other ways of doing it. So yeah, but I will do it like this. So this one I'm going to turn into construction. I'm looking for a sketch tool right there. It's construction. Okay, you can see that. Actually, you can see that there is, if I hide this thing, you can see the sketch right there. Let me undo this, okay? And directly looking at it from the front. All right, now, please note that there are many different ways of doing this problem. Here's how I'm going to do that. So I'm going to draw a circle here, but make sure that circle is actually on the center of it is on that construction curve, okay? For example, I can say here, there. This is not to be construction though, because I want to make a pocket out of that, right? And exit and make a pocket. There we are. Notice that I could have also used this thing, which is the hole option, but I'm not going to do that. You can try it yourself. Good. Now I want to make a complete crown of this. Now, how do you make complete crown? So you go, oh, you know what I forgot to do? I forgot to dimension these things. So let's go back to that pocket, back to that sketch. Let's dimension certain things. For example, dimension this guy. This is going to be our mid, right? And dimension this guy. That's going to be R of the whole, okay? And exit. Good. Now, let's make a complete crown. Look for circular symmetry, right there. Circular pattern. That's what I meant. Circular pattern. Okay, no problem. Let's cancel that. Let's go all the way to the top. All the way to the top. Okay, so circular pattern. Oh, the selected body isn't associated with the current body. No problem. Okay, let's do. Let me cancel. Tell you what this thing is saying. You want to make a circular pattern, right? So you want to be in the part body, right there, part body. See that? Part body. Right click, define in work object, right there. Now, when I do circular pattern, I don't get that message because this part body is where it's going to hold, it's holding these things and it will hold my circular pattern. Now, let's see now. We want to do a complete crown of what? Not of the entire current solid, but of this pocket that I made. You can select it from here. And how many of them do you want? Let's say, for now, let's say 4 and see how it looks like. And it says, what is the reference element? In other words, let's put it this way, what is the direction along that axis that the crown is made? For example, I can select this side face. Or I can right click because of the way I've done it. I can use the Z axis, okay? Or I can select that top face. It doesn't matter. It'll give you the same thing right there. See that? Let's make it, I don't know, 7, 8. That's fine. There we are. Now I could have done this thing with a hole, but I decided to do it with pocket. Now let me change the rendering here so that I don't see these hidden edges. Yeah, good. All right. So the question becomes, how are these guys related to the dimensions that I have here? Right now, you can change these things. You have no idea what to do with this part. So here's what we're going to do. You click on f of x, and what you do is you say, show me all the parameters. So don't show me everything. Show me just the renamed parameter, the ones that I made. See that? These are the ones that I made. And if you put the cursor on the part or on the tree and you click on it, all the stuff that you need will appear. However, notice what happened here. I have the padded height. I have the radius of the big circle. I don't have the other fellows, but all you have to do is to select on the circle, for example, let's say on the pocket. Yeah, you see, the radius of the pocket appears. The radius of that circle that actually has the center of these circles on it appear, etc. So we got to start somewhere. Let's start with this. All right. So, and then I say, show me all the parameters in case rename parameters. Okay, show me everything. Fine. So this guy, you see this? This guy, add a formula. What are the parameters? Rename parameters that I made. This guy is R mid. There. I just say OK. Now, the reason that this is red is that you're changing the value that it was before. So it wants to update. In fact, if I apply it, if I say apply, now it's going to readjust this thing, update this so that it takes the value of R middle equal to 4, which actually did, right? Like it did already. But if I say apply, this is going to resize. There. Obviously, that was not a good idea because that number is too big. You can see that, but you can always fix this thing. Let me undo that. Let me undo. Okay, good. But we made the equation. This fellow is the height of the pocket, right? Is the height of the pocket. Now, I think the pocket was all the way through. This is a pad. I'm not sure. Let's check it out. This is the pocket size, okay? And in fact, when I did it, I should have done all the way through. Maybe I didn't, but that can be fixed. There's no problem. We can fix that. Let's go to the pad. Let's go to the pad. Here is the first limit of the pad. Look, it's selected it. That's the height of this. Add a formula equal to rename parameter. It's H. Double click on it. And notice that if I apply, this is going to resize, okay? Good, it did resize, but it doesn't go all the way through because of the fact that I had when I made the pocket, I didn't say all the way through, I said a dimension. Okay, I'll fix this, no problem. Okay, so we got that. Now, did we do our? Let me see now. We did radius of the hole. Did we do radius of the hole? I don't think so. Okay, so where is the hole here? The pocket, actually, right there. And this guy, this is the not that guy. This guy, this is the radius of the hole. You can see that right there. See that? Radius of the hole. Add a formula equal to rename parameter, and it is R of the hole. And if I apply, it's going to resize, right? But I'm not going to do that. And then let's go to the original pad, the R big now. We're going to set the R big. Original path is here. There is your R big. Add the formula equal to R big, and we say OK. And let's see what happens. When we say OK or apply, everything is going to be resized according to these numbers. Now, the only issue is that this didn't go all the way through. So that's easy. We go to our pocket that I made. See that here's the pocket. Here's the pocket. Don't go by dimension. Go all the way to the last, and it goes all the way through. Right there. You can see that. All right. So what does parameterization mean? We go and change these things. For example, R big. Can I make it smaller? Can I make it bigger? 7. Okay, bigger. R mid, that's the radius of the circle where these things are located. Can I make it maybe 6? It's already, what is that? It was already 6. Okay, so let's make it 5. Wait a minute, R mid. Oh, you know what? I think we must have forgotten. We must have forgotten to do R mid. So let's check it out. It did these R mid. I forgot to do that. Okay, so let's go do it. That's why nothing is changing. So no problem. You go to f of x. You go to f of x. You select on the part. And that was in the sketch, right? That was in the pocket sketch. It's this guy. This guy, we forgot to do it, or add a formula. I did forget to do it. So rename parameter or mid. Okay, let's apply. Yeah, you see that? It does change. Okay. Oh, the other thing is that I have to do n, right? Let's go on the f of x. Click on the part and look for the place where the number in the circular pattern is listed. So the easier way is to select on the circular pattern, so you get only the information for the circular pattern. It's right here. You see that? Right here. Angular number. So add a formula equal to n. By the way, you can select the n from the tree too. You can select it from there or from there. It doesn't matter. And right now 6. And I say if I say apply, obviously it gives you only 6. You can see that. Say OK. So let's check. For example, if I go to n and say 15, there we are. If I go to R mid and say I don't want 5, I want 4. There. If I want the radius of the hole, instead of being 0.2 to be 0.5, now make sure that if you make it too big, obviously they're going to interfere with each other, which is fine. There's nothing wrong with it. There. If you make it too big, obviously H is going to work. H is 3, no problem. And our mid, our hole, if you make it 1, there's no problem. They're going to cut through each other. So let's see now. If you make it 2, see how it works. There we are. So this was our first example, right? That guy. So, so let's go to our second problem. The second problem looks like that. So I want these to be parameter x, y, z, r, and t, and they're given here. Z, for example, is the height path. T is or r is the radius of this. X is length. Y is length, etc. But I also want serial number to be there. So the name of the part I also want to be one of my parameters. Okay. So let's go make first. Let's go and make a list of parameters like that. X, Y, Z, R, T. So with some nominal values, you can take one of these as the nominal values. So for example, X is 10, Y is 5, Z is 3, and R is 1, and T is 1. Okay. Now, you might say, wait a minute, what is this thing that looks like a table? Because later on, when you do design table, we're going to come back to this problem and create Excel spreadsheet for us, which is called design table. So anyway, let's go here. Start with the part file. You know what I'm going to do? I will make actually a piece and then mirror it. How about that? Would that be okay? Yeah, all right. So let's do that. So on that plane, I will sketch something that looks like what I have. Except that this I wanted to go the other way around. And the other way around part is a problem because, hey, you know what? Yeah, so let me do it a different way. So we go here. There, we're going to clean it up, okay? So what do I mean by cleaning it up? So first of all, I want this point to be on that. Where is that? Control that to be coincident. Okay. And I'm pretty sure this is 90 degrees, coming in at 90 degrees. If I'm not sure, we can always check it. Let me draw an arc here. See whether it closes on it. So yeah, you can see that. Oh, cancel. Very good. Okay, good. So let's put some dimensions. You know what? I'm not going to put any dimension. I'm going to mirror it right here. Because, well, I'm not going to put any dimension because X is this whole thing. You know, so, all right. So let's see now. What do we want to mirror? 1, 2, oops, control, right? 1, control this, or you can trap them too, and this and that. You're going to say mirror with respect to this. Very good. And now we're going to put dimensions here. So dimension this whole thing from here to here. Okay. And we need a dimension from here to here. Okay. What else do we need? T is from there to there. And R is the radius of that. And I think this is fully constrained, as you can see. So exit, pad it. There we are. So basically what we've got here is a replicate of that guy. All right. So now we start creating our parameters. So we go to f of x, not real, length. First one, I'm going to call it x. And don't give it value 0 because it's just source of confusion. Or you can leave it at 0 and then go change it from the tree. That's up to you. So I'm going to leave it at 0, okay? Another one, y. If you want to see it in the tree, by the way, here's, yeah. Oh, I did not do the first one. So x, let's do x, apply. There we are. Another one, new parameter, y, new parameter, z, new parameter, t, new parameter, r. Okay. Now this next one, I want it to be a string because it's a serial number, right? So I'm going to say, okay, not real, but let's see now, is a string, and I'm going to call this thing serial number, okay? Yeah, apply, and okay, right there. Oh, you know what? Yeah, we have the padded height is actually Z. Very good, very good. Now, let's use these numbers and put the first row here so that we're not surprised later on. So 10, 5, 3, 1, 1. Okay, so let's go here, make it 10, 3, what was that? 10, 5, 3, 1, 1. So this we're going to make it 5. So this is 3, 1, and 1. Oh my God, this should have been. This is wrong. Let me go back there. Let me go back there. Let me go back to f of x. This is not type equal to inches. It should be string, right? So I screwed up here. So let's go back here. This one, the type should change. It should change the type. Let me delete this. First of all, I'm going to delete this. Delete parameters. Fine, no problem. And then I'm going to create a new parameter, string, okay, and we call it, I'm going to call it serial number, right? Serial number. And let's give it some dummy name, AAA. Okay, good, you can see that. Now we're going to associate these things with things that I have created or dimensioned here. So you go to f of x, you click on everything. This, for example, is going to be add a formula equal to y, but I know y where y is. I can do it from here, or you can say rename parameter y. There we are. Okay. That guy, when I say this guy, I mean this, okay? Add a formula equal to x, okay? Where is the padded height? The padded height must be somewhere here. Oh, right there. This guy, add a formula equal to z, okay? Yeah. That fellow, let me see now. This fellow is my t. Notice that when you do that, these things resize. Okay, so if you want, before you proceed later, just say apply so that it repeats it. So or update it. So this is t, and finally the circle radius right there. Add a formula, that's r. And it's possible to make mistakes, so don't worry about it. Now, let me go under the part name and find the part number, because there is no such a thing as there's no such a thing as part name. You have to look at the part number. There's the part number right there. See that? Part number. Add the formula equal to serial number. Okay. And okay. All right. We're in business. Look, AAA. If I change the name to BBB, the name on the top changes. If I change the padded height from 3 to maybe 0.5, this becomes thinner. There. If I take x is that length. If I from 10 I make it 15, it becomes longer. If I take, for example, y was this thing, make it 7, okay, etc. And then the t and the r, t make it 2. Oh, I forgot to do the t. I don't think I have an equation for the t. You can see that I've done everything but t. You can see that. That's why when I change this t, nothing changed. When I change the r, there's no problem. When I change the r, for example, let's make it 2. That changes, but I forgot to do the t. No problem. You go to f of x, click on the screen, get the t. I think it was this. I think that t was this right there. Add the formula equal to t and say okay. Apply. There we are. Okay. Change the t to 3. Let me close it here for t equal to 3. Okay, there we are. Now remember, if you put an unreasonable number, surface may become intersecting, self-intersecting. For example, if I make this t less bigger, let's make it t equal to 4. Okay. Remember, this y itself is 7. You have 4, and then on top of that you have the radius. So actually, let me make this thing 6. You're gonna have a problem for sure, right there. Because look at the surface. If you go to the surface or the sketch, you made that thing too big. Anyway, we have done the problem, and that takes care of this example. Okay. Okay, so this is going to be my third example. Now notice that here we have parameters of type angle 2, and we also have parameter again of type string, 2 of them. One is the name, the other one is material. So what we're going to do is to take a nominal part like that and then create our equations. Of course, we also have to do the parameters. So let's go here. I'm going to get rid of all of this. Start with the part file. Okay. Should I make my parameters? Okay, let's do that now. F of x. So let's start with a string. I'll call this thing serial number. Serial number. And let's give it some dummy name. So I'll call it the AA. Apply. Here is in the tree. You can see that serial number AA. And another one. Call it material. I'll call it, again, of type string. What did I call this thing? Mat, M-A-T. Okay. M-A-T. M-A-T. I'll just put some dummy name here. For example, gold. It really doesn't matter because later on we're going to change these things. Now we took care of those. Now let's do some angles. So apply. So type is angle. Let me do the length first from the top. A new parameter of type length. I'll call it big L. Value of 10. I'll use one of those rows. Another one. I'll call this thing B. That's the height on the top. I'll make it 8. Apply. What I'm getting is I'm using these numbers on the top. Yes, I call this thing AA and steel, but that's okay. We'll get there, not to worry. And what's the next one? R top, radius on the top. Another one. R top. R top. And what value do I have here? R top is 0.5. If you want the spelling to be exactly the same thing, lowercase, uppercase, etc. Another one. Another one, R side. R side. Radius on the side. And 0.3, I think it was. 0.3. Apply. And the the pad length is 2, so there's no parameter associated with it, just a constant. All right. So we need, what do we need here? Angles. Okay, angles. So let's change this thing to angle. One called alpha. And I think the value is 60. Remember, my units are in degrees, so that's fine. Another one, beta. Beta. And 70. Apply and OK. Notice that these are all created. Okay. Now we're going to create a nominal part. On that vertical plane, I will sketch that trapezoid, it looks something like that. Okay. Dimension some stuff because this is going to be my L eventually, so I need to dimension it. This is going to be my B eventually. I'm going to dimension it. This is going to be the angle alpha. And this is going to be the angle beta. And when I do that, everything is going to be, oh yeah, the reason not everything is green, because the location of this with respect to the y-axis is not fixed. But that's okay, no problem. By the way, if right now I just made some degree, some angles, whatever it happens to be. Later on, I'm going to say this is equal to, sorry, alpha, and alpha is 60, for example. That's okay. So exit 2 inches, padded by 2 inches. Good. On the top, I sketch a circle exactly in the middle. You're told that this is centered exactly in the middle. I have to clean it up then. So I draw it like that, and I can dimension it. And then I want it to be exactly in the middle, so we know how to do that. This line, control that line, control the center. You're going to make it equidistant. And left side, control, left edge, control, right edge, control the center, which I don't know where it is, right there. And I want this thing to be equidistant too. Very good. Exit, pocket, all the way to the end, all the way to the last. So it goes all the way through. Okay, now I need a circle on this side, on this plane. I will sketch. I do exactly the same thing. Fit it. Draw a circle. A circle like that. Clean it up. So left, control right, control center. You make it equidistant. Up, control bottom, control center. Oh, no. Undo. Undo. What are these? I think these things I have to delete from the tree. It's easier if I went to the tree and find out what they are to delete it. Oh, this is parallel. I'm going to delete that. Yeah, delete this. Do it again. Left line, control right line, control the center here, equidistant. Oh, maybe it was okay. Top, control bottom, control center, equidistant. I didn't realize that it does actually this thing, so which is fine. And dimension it, because later on this is going to be our side. Exit, and then pocket, all the way to the end. Pocket, all the way to the last. So there we are. Okay, good. So now we're going to go to f of x. Oh, you know what? I haven't applied material property on this. So let's go ahead and apply material. So there's apply some dummy material. So metal, aluminum on this part. There we are. And we say okay. Good. So now we're going to go to f of x. All right. And if you click on this, the stuff that you need are going to appear. For example, here's the angle beta. You select that, add the formula, equal to beta. Where is the beta? Beta. Okay. Now notice that this number changed. The actual part has not changed, but that number changed. Okay. If you want to even the part change, you can say apply, but I'm not going to do that. This guy, add the formula, equal to alpha from the tree. Oh, alpha, look at that, inches. No problem. So this one we're going to delete. I'm going to delete this. I'm going to delete this relationship. So delete the formula. Delete the formula. Delete this formula. We say okay because I really because I resized. Remember. So let's go here. Cancel that. Let's go to f of x and delete that and make another alpha with the proper unit. So f of x. There's my alpha. This should be. Let me delete this. Delete this parameter. Make another one of type angle. So new parameter alpha 60 degrees. Good. Okay. So now let's go back to f of x. Click on that. This is the angle alpha. Add the formula alpha. Remember, we got a message that this is, yeah. Let's select this. Add the formula. That's equal to b, right? B is from the tree. Another one, this bottom one. Add the formula. That's equal to L. Okay. And what about these things? Let's check R top. Oh, if I cannot see R top here, there's a good reason for it. Because that was done in the, let me see now, in the pocket, for example, right there. So this guy, I selected on the pocket. I can see this radius now. Add the formula. That's equal to R top. Now remember, here R top is 0. Okay, so we're not going to get anything. Later on, I'm going to change these so that you can see what's going on. That's a bad idea to have 0 there because you will get confused. And then there was another pocket which was on this side, and this, which one was it? Was it this side? No. Where did we make this? Oh, this was also that pocket. Okay. Anyway, it's possible to make mistake. We're going to fix it. Add the formula. This is our side. Where is our side? I didn't do our side. Parameter our side. I was so excited, so I didn't do that. So let me cancel that. Cancel that. Now, because these numbers are unrealistic, we are getting an error message. I can see that. So let's go ahead and put these numbers. It's a good idea to put numbers that make sense. 10, 8, R top 0.5. So R top, make it 0.5. Okay, there. See that? I forgot to do the R side. No problem. We go back there. This is going to be not angle, length. Add the this is a parameter called R side. R side. And let me give it a value 0.3. Apply. Okay. So now when I go to f of x, and I click on this, or click on this pocket, I get my, right there, this is R side. Add a formula equal to R side. You say okay. Okay, let's go and, first of all, before we do the material, let's go and check, make sure these things make sense. For example, let me change the B is this, okay, B is this. So let me go and change B to 6. There. Let me go and change L. L is this to 12. There we are. Let me go and change the angle alpha, or not this, angle alpha to 90 degrees. So that side becomes vertical, basically. You know what? I'll make it 45. Oh, I forgot to do the angles. I forgot to equate the angles. What about this one? Did I do this one? No. Let's go back to f of x. Cancel. Let's go back to f of x. Click on that. I think I did beta, but where is the equation? This is beta. Okay, that one, that's fine. This equation was made, and this is alpha and this is beta. So how is it that why are they not working? Let's check our relations. Let's check our equations. So that's good. It should work. So let's go ahead and change the 70 to 90 vertical. So something is inconsistent here. Let me undo this. Let me make the angle beta smaller. So 50. Okay, that's good. And let me make the angle alpha to 90. This angle alpha, this one, this equation, obviously, oh, they're both beta. Darn. So one of them, let's go to this one and make it alpha. You have to do these patiently. There. Okay, so let's put it back. Let's put it back to, from 90, put it back to 60. 60. Check the radii on the top and the bottom. So our top right now is 0.5. So let me make it 0.2. It's going to become smaller. You can see that. Let me make this thing a little bit bigger. Our side, where is our side? Right there. Let me make it 0.4. Remember, if you make it too big, it's going to cause a problem. It's going to cut these sides. So you can't just go ahead and randomly put any number that you want. Now, the only thing that I have to do is the material and the part name, which I decided not to do because we wanted to check these things. That's easy. So we go and click on the part. Okay, go look for part number. Where's part number? Part number. Add a formula equal to serial number. Okay, and let's go look for material, because remember I put a dummy material there. Let's go ahead and find out. Let me click on this top again. Aluminum, right there. You guys see that part. These are the material properties. Where is the material? So let me click on this mat right there. Where's the name? These are the actual numbers. I want the name. So let me go the following. Go all the way to the top. Let's look for math. There must be a material. There must be material here. So let's see now. We found the part number. Let's see now. Material right there. Add a formula equal to that dummy thing that I put in there. Now, yeah. Okay, so let's check it out. The material better be gold. There it is. The part name must be AA. Now let's go change it. Serial number. I don't want it to be AA. I say my name. How about that? Name. What it's going to do is going to change the name to name of the part to this. Now, as far as the material goes, you can't just go and randomly type whatever you want, because if you put, for example, lowercase silver, but if you put lowercase silver, it's going to come back and say, I don't know. There is no such a thing, lowercase silver. So you have to change this thing to big S. Okay, and change the material to silver. So this was our third problem, right? Very good. Now I'm going to quickly do this problem for you. So we have alpha, fillet radius, length of the shaft, and what do we have here? radius of the handle, radius of the fillet, angle alpha, and length of this, and the material serial number. Okay, so let's quickly do that. All right, let's start with the part. Let me define my parameters, f of x. Let's do the length first. Radius of the handle, or h. Let's give it a value, 6. Another one, radius of the fillet. It is always a good idea, if you have things, use it. So RHB1, RFB 0.5. Now RH is not critical, but RF is 0.5, okay? So we make it 0.5. Another one. What else do we have here? Length of the handle, right? I think it's, yeah, right, length of the handle. Length of the handle, LH. Length of the handle, this RH also is critical because it's the radius of the handle. You know, if it's too big, then you're going to have a problem with that, but that's okay. So LH is 10. So where is this? LH, 10. Okay. And then alpha. Now, alpha, you have to change, obviously. You have to go to angle, click on it, new parameter, call it alpha. Say OK. Now, I didn't do the serial number and the part number. Maybe I should do that. I'll do it. Okay, so we go here and do another one, string. So should be on the top. New formula. I'll call it serial number. And I'll call this thing AAA. Okay. Another one, material. So I'll call it MAT. And I'll call it, give it a meaningful name. So how about brass? Big BRASS. Apply. And let me say OK. Now let's go make the nominal part. So on that plane, I will sketch the hammer handle. No, the hammer head. Something like that. There. And there. OK. Now, if you want these to be tangent, because it's a fillet, really, so this control that, make a tangent, or you can make a fillet there. It's up to you. It doesn't really matter. So let's see now. Angle alpha is between this and that. Radius of the fillet is right here. Exit, pad it. Let's make it big enough so that we can actually draw a circle on this side. On that face, I will sketch the circle. If you cannot see things properly, so change the rendering there. So there is the middle of the thingy. And of course, you can make center this thing. I'm not going to bother. Please, you can do that yourself. Maybe I should bother. Left control, right control, center. Equidistant, you can also do it from the top, but that's okay. So I need this dimension, exit, and pad it. So this is the nominal. This is the nominal hammer. So now we're going to go and click on f of x. Click on that. That guy, add a formula. That's the radius of the fillet right there. That guy, add a formula. That's alpha. It says 0 degrees. That's going to cause a problem. You know that. Let me change that thing from 0 degrees to, I don't know, maybe 50 degrees. Okay. What else did we have here? So this thing, that is the hammer length. This is the hammer. This is the radius of the hammer. Add a formula. Radius of the shaft actually handle right there. And finally, this is the length of the handle. Add a formula equal to length. Let's make sure that the dimensions are all working, and then we worry about it later on. Wow, wow. That's because, where is that? The radius of the handle, 5. No way, man. So that's going to be 0.2 there. Radius of the fillet, let's make it point. If you make it 0, there won't be any fillet here. So, for example, I'll make it 0 to show you that there won't be a fillet there. We can see that. The angle alpha, make it 90. There won't be a meaningful, this is a very artificial hammer. Now we're going to do the part name and material. So first I better put a dummy material on this thing. So let's say put aluminum on that, because we're going to need this name. So now we're going to go to f of x. Where is that? F of x. First, let's find the part number. Part number must be somewhere here. There's part number. Add the formula equal to serial number. Notice that it changed, AAA, because I had it in my tree as AAA. And finally, let's go find the material. There, this material, add the formula equal to MAT. It's going to change to brass. For aluminum, it's going to change to brass, because that's what I have there. There. And we say, okay, let's go and figure out. So first of all, serial number. I'm going to call it 1, 2, 3, 4, 5, 6. Okay? Look at the part name, 1, 2, 3, 4, 5, 6. Material. From brass, let me change it to steel. Big S T E E L. Say okay. See, it changed. And change, we already tried these. For example, I'll make alpha 45 degrees. And there we are. So that wraps up our discussion for parameterizing a part. Good luck. See you on Thursday.